So here's projectile motion 3.4, 3.5 in your text. And projectile motion is basically combining the horizontal and vertical motion of what we have done a few weeks ago to apply it in the same motion. So before we're dealing with unidirectional motion, motion in one direction, whether it's horizontal from left to right or right to left, or up, down, down, up, and back down again. That's basically unidirectional. And now we're dealing with both directions, horizontal and vertical. So now we have the situation where we have a projectile motion. Now let's look at horizontal motion really quick and just looking at a projectile being launched horizontally. So what happens now is that the horizontal projectile will not include a vertical initial motion, and so as it begins to move in a parabolic path, we will see that it has a pretty distinctive features. So we'll use this as our starting point to analyze the motion. So if you look at this cannonball being fired from the cannon, and as it begins to go through the air, ignoring air resistance, it will travel a pretty consistent path. Each of those red dots represent 1 second intervals. So as the cannonball flies through the air, time is elapsing. But one thing you should also take notice is that on the bottom here there is an x velocity and a y velocity. Okay. Now in the x velocity, the cannonball is going to be shot out at this speed of 100 meters per second. But that speed, if you notice, doesn't change as it is falling into the canyon, because the reason that the velocity doesn't change its speed and its direction is because there are no other forces in the x direction to act on the cannonball. All the forces were applied at the beginning to propel this cannonball out of the cannon. But as soon as that force has been spent, the velocity is now constant, because as you remember, force causes acceleration, a change in acceleration, and acceleration causes a change in velocity. But because there is no additional forces acting on the cannonball will not accelerate. If there's no acceleration, there's no change in velocity, which causes the velocity to remain at a constant rate. Okay, so now if you look at the y velocity, the vertical velocity, the speed increases as the direction remains downwards. So if you notice that the velocity downwards increases by a rate of about 10 meters per second every second. That's not a coincidence. That's not by design. That is actually about how fast the gravity is going to affect its acceleration, causing the rate of velocity to change by a rate of 10 meters per second every second. Okay, so if you see that value increasing, it's because the velocity is affected by the acceleration due to gravity. Whereas in the x direction, there are no other forces, so therefore there are no acceleration, and therefore there is no change in velocity. Now, there is a classic story in physics about a hunter going into the jungle trying to shoot monkeys. So he brings his rifle and he sees a monkey out in the distance on a tree, hanging on a tree branch. So he aims the gun at the monkey, and now if you were this hunter, are you going to aim this gun at the monkey, above the monkey, or below the monkey? Because what happens is when the gun goes bang, the monkey will let go of the branch, okay, and it begins to fall. So are you going to aim the gun at the monkey, above the monkey, or below the monkey to shoot this monkey? Now, of course, we are in a public education system, and there are a lot of politically correct individuals, so I have to modify this to a banana cannon as opposed to a gun, because animals cannot be harmed during this course. So banana cannon is to shoot bananas at the monkey to feed the monkeys their snack. So should I aim my banana cannon at the monkey, above the monkey, or below the monkey? Okay, so that's a question that I would like you to think about. But let's just say I'm able to turn off gravity and I shoot the banana cannon at the monkey. Will the monkey catch the banana? So if you look at this animation, you would notice that the monkey does indeed catch the banana. Since there is no gravity, the banana will go in a straight line path, and when the cannon goes off, the monkey lets go. It won't fall because there's no gravity to cause it to fall. Okay? So, what do you think? Back to the original question. If I was to aim my gun above the monkey with gravity turned on, will he catch the banana? Pause, think about it, and then replay this section. So if you aim the banana above the monkey, unfortunately, the monkey will not catch the banana. Okay, seems kind of obvious, right? Each blue dot represents 1 second time interval. So if you count the number of dots by hitting pause on your screencast, you would notice that the amount of dots are consistent with the banana cannon going off, going towards the monkey, and the monkey falling. That should give you a clue as to other questions I will be asking tomorrow. Now, what happens if I were to tone down gravity a little bit so that the monkey will fall at a slower rate, but I aim a banana cannon at the monkey? Will the banana cannon hit the monkey, and why? So I go ahead and pause and see if you're able to answer the question. So if I aim the banana cannon at the monkey will hit the target of the monkey. As the monkey is falling, the banana is falling. And because the banana and the monkey are falling because of gravity, and gravity pulls all objects with the same acceleration, the acceleration due to gravity, which is approximately 10 meters per second every second downwards. So since the monkey and the banana will fall at the same rate, the banana and the monkey will intercept each other at a specific point. Now, what happens if I turn up gravity, making gravity stronger? What will happen then if I was to aim my banana cannon at the monkey? Will the monkey catch the banana, or will it miss the banana? Go ahead and explain your answer. And then hit pause, rationalize it, explain the answer, think about the answer, and then hit play again. So if I aim the banana at the monkey, the banana will also be intercepted by the monkey because both the banana and the monkey will hit the target. It actually looks like the banana cannon is going faster, so it's not high gravity, but high initial velocity from the cannon. Okay. So here are some rules for projectile motion. We are going to break the problem down, the projectile motion problem down, whether it's horizontal or vertical motion, into two interconnected one-dimensional problems. So moving in one direction. So we'll break it down to vertical motion, as we did in free fall, and the horizontal motion, as we did with your mousetrap car. And we're going to combine the two in some way, but we're going to solve for them independently from each other, because from your reading, the motion in the x and motion in the y are independent from each other. We're going to treat the vertical motion of a projectile just like a free fall problem. Okay, just like we did when we did the free fall unit. And the horizontal motion of the projectile is just like a constant velocity problem, where we have the constant velocity because there is no forces acting on the object anymore, therefore no change in acceleration, therefore no change in velocity. So we have a constant velocity. And now we are going to connect the vertical and the horizontal motion together by the variable of time. the time used for the vertical is the same as the horizontal. Okay? So, looking at these four rules, it doesn't exactly tell you how to solve a problem. So we're going to attempt to solve the problem on the next slide. So here's an example problem. So let's just say that you're standing on a cliff, admiring the sunset, and you accidentally threw your car keys horizontally at 8.0 meters per second from a cliff, 64 meters high. And of course you need to drive home, so you're going to climb down this cliff to search for the keys. So how far from the base of the cliff should you look for the keys? Go ahead and hit pause and see if you're able to divide the motion up in horizontal and then divide the motion up as a free fall problem. Okay, so remember your velocity in the horizontal is constant, so you're going to use only the equation for your constant velocity equation, which is velocity is equal to distance over time. And when you're dealing with the vertical motion, use those four equations with the change in velocity, change in distance, and acceleration, so the constant acceleration equations from your equation sheet, to solve for that. Don't mix the numbers together except for the time. The time is pretty much shareable between the vertical and horizontal. But the numbers you use for the vertical and the numbers you use for the horizontal, for the most part, will be different. Okay, so you see over here, the 8.0 meters per second, that in itself is not the vertical motion. This is horizontal, as it says right here, horizontally at 8.0 meters per second. So this is how fast it's moving horizontally. Whereas the vertical motion starts off here from a cliff 64 meters high. So then you only have one piece of information, one explicit variable that's given to you in the problem, but you should be able to come up with all the rest if you were to remember how to do the free fall problems. So divide it up in the two sections, the x motion and the y motion, and then see if you're able to come up with a solution. The answer is given as 29 meters from the base of the cliff. So go ahead and try to solve for it. You might get stuck. I'm pretty sure you will get stuck. And also try checking Google. Search for projectile motion problems and see if you're able to find a website to help you with solving this, and then come back to this problem and see if you can do it on your own. Alright, so we'll go over this problem in class tomorrow and see if you're able to figure this out.